In 1965, a chemist named Stephanie Kwolek made a batch of liquid polymer that looked wrong. And for the record, that solution was cloudy and pale, opalescent, like watered-down milk, not ink dark navy. If your polymer looks like the deep end of a pool, you've got a different problem. Cloudy, thin, her supervisor took one look at it and said, throw it out. She didn't. She talked the technician into spinning it anyway. And what came out of that spinneret was a fiber 5 times stronger than steel by weight, from a solution her boss said was garbage. I need you to understand. The material that stops bullets exists because one woman said, no, I want to spin the weird one. Kevlar is a polymer, a long chain of repeating units like a bead necklace, except each bead is a ring of carbon and nitrogen atoms linked by what chemists call amide bonds. I said rings, aromatic rings, flat hexagonal carbon rings. Those are spheres. Kevlar's repeat unit is paraphenylene, not a bag of gumballs. Same family as nylon, but nylon's chains are floppy, they curl, they tangle. Kevlar's chains are stiff, perfectly straight, rigid rods. Picture a bowl of cooked spaghetti versus a box of dry spaghetti. Nylon is the cooked version. Kevlar is the dry box. That stiffness changes everything. Here's why that matters. When you dissolve Kevlar's building blocks in sulfuric acid and push them through a tiny hole called a spinneret, those rigid chains line up side by side. They do this on their own. The solution forms what chemists call a liquid crystal. The molecules organize themselves like soldiers before you even ask. Then they lock together with hydrogen bonds. Millions of tiny molecular handshakes running along the entire length of the fiber, every chain holding onto every neighbor. The result is a material where breaking one fiber means breaking every bond at once. You can't unravel it. You can't pull it apart one strand at a time. You have to snap the whole thing or nothing. That's why Kevlar has a tensile strength of about 3,600 megapascals. Steel sits around 400 to 550. Kevlar is 5 times stronger and it weighs a fraction of what steel weighs. It can handle temperatures up to 500 degrees Celsius before it starts to break down. It doesn't rust, it doesn't corrode, it bends. You've seen it: body armor, bulletproof vests, motorcycle jackets, aerospace panels, racing tires, hurricane sails, the tires on the Mars rovers. Kevlar is everywhere. You need something light that absolutely cannot fail. Now, here's the part of the story that doesn't show up in the brochure. Stephanie Kwolek made this discovery at DuPont in 1965. She was a bench chemist. She had been at DuPont for about 17 years at that point, working on polymers. She was not running a research program. She was not a department head. She was the person at the bench doing the actual chemistry. DuPont patented Kevlar, DuPont built the factories, DuPont made billions with a B by 2020. The global aramid fiber market was worth over $3 billion a year, and Kevlar dominates it. Kwolek held 17 patents by the time she retired. She received the National Medal of Technology in 1996. She was inducted into the National Inventors Hall of Fame. But she never got rich from it. The patents belonged to DuPont. That's how corporate research works. The company funds the lab. The company owns the output. The chemist who trusted her instincts over her supervisors gets a medal and a pension. The company gets a multi-billion-dollar product line. I'm not saying that system is evil. I'm saying you should know whose hands were in that flask. Kevlar exists because someone looked at a solution that didn't match the textbook and chose to be curious instead of correct. That's the whole story. A rigid chain, a hydrogen bond, a woman who wouldn't throw out the weird batch. Thanks for watching. If you want more substances that earned their place in the world the hard way, subscribe. We do this every week. Next time you put on a vest, ride a bike, or land a rover on Mars, remember the cloudy flask from 1965? That's polyparaphenylene terephthalamide.